Have you ever considered building with paper? It sounds unusual, but it is a real possibility. A unique material called papercrete makes this happen. It is a lightweight building material, created by mixing simple ingredients. The main components are recycled paper pulp, Portland cement, and water. This innovative mixture turns what we often throw away into something strong and useful. It challenges our ideas about what construction materials can be. Papercrete is a meeting point between recycling and building, offering a sustainable path forward for projects big and small. This material first emerged in the 1980s. Inventors developed it as a more eco-friendly way to build. They saw vast amounts of paper waste headed to landfills. They also saw the high environmental cost of traditional concrete. Their solution was to combine the two worlds. The core idea: transform discarded paper into a construction resource. This reduces landfill waste and creates a material with excellent insulating properties, making homes more energy efficient and comfortable. Today, papercrete's relevance is greater than ever. We face growing concerns about waste management and climate change. Sustainable building is now a global necessity. Papercrete offers a practical answer. It provides a low-cost solution for builders, especially DIY builders. Because it literally turns trash into building material, it has earned the nickname Trashcrete, That name captures its resourcefulness and role in a circular economy. The potential is vast and exciting. Imagine walls for a small cabin, planters for a garden, unique sculptural forms. Papercrete makes this accessible. It is lighter than concrete, easier to handle, and provides superior insulation against heat and sound. While it has specific uses and limitations, its benefits are compelling. This guide will walk you through everything you need to know, from creation to practical applications in the real world. This guide is designed as a chapter deep dive into the world of papercrete. We will explore every aspect of this material in a clear and structured way. The goal is to give you the confidence to make it, use it, master it. We will begin by answering the most fundamental question: what exactly is papercrete? We will break down its composition and discuss the role of each ingredient. You will learn why some builders add materials like sand, clay, how these additives can change the final properties of the papercrete. Next, we will move into the practical process of how to make it. This section will serve as a step-by-step tutorial. We will cover sourcing your materials, shredding and soaking the paper, achieving the perfect pulpy consistency. We will provide guidance on mixing ratios and techniques, whether you are mixing by hand for a small project or using a machine for a larger build. Pouring the mix into forms and ensuring a solid final product will be explained in detail, along with crucial tips for the curing process to prevent cracks and ensure strength. After you understand how to make it, we will explore its properties, advantages, and limitations. You will discover why papercrete is so lightweight and how its fibrous structure makes it an excellent insulator. We will discuss its fire resistance, its versatility for different shapes, and its significant environmental benefits. At the same time, we will address its drawbacks, such as its lower structural strength compared to traditional concrete and its sensitivity to moisture. Understanding both the pros and cons is essential for using the material successfully and safely in your projects. Finally, we will look at interesting and realistic uses for papercrete. From insulating infill walls in eco-homes to creating beautiful garden structures, you will see how others have put this material to work. We will provide actionable ideas for your own projects, whether you are a beginner or an experienced builder. This guide aims to be your complete resource, empowering you to turn waste paper into a durable and sustainable building material. For those watching this as a video, subtitles will appear at the bottom of the screen for accessibility. Before you can begin making papercrete, you need to gather your materials and tools. The process is straightforward, and the items are generally easy to find. Your primary ingredient is, of course, paper. You can use a wide variety of recycled paper products, such as old newspapers, junk mail, office paper, cardboard. Avoid glossy magazines or paper with a waxy coating, as these do not break down into pulp as easily. The more absorbent the paper, the better it will work. Sourcing this material is often as simple as collecting it from your own recycling bin or asking friends and local businesses for their paper waste. This is the first step in turning trash into treasure. Next, you will need a binder. The most common binder for papercrete is Portland cement. This is the same type of cement used in traditional concrete and is widely available at any hardware or building supply store. The cement is what gives the papercrete its strength and fire-resistant qualities. You will also need a consistent supply of water, which is used both to create the paper pulp and to mix the final slurry. Some recipes also call for optional additives. Sand can be included to increase the compressive strength and reduce shrinkage. Clay can be added to improve the texture and workability of the mix, making it more like a plaster. The tools required are just as simple as the ingredients. To break down the paper, you will need a way to shred it. A standard office shredder works well for small batches. For larger projects, you might consider a more robust garden shredder, or even a specialized pulp mixer. You will also need a large container for soaking the paper, such as a 55-gallon drum, a large plastic tub, an old bathtub. For mixing the slurry, a heavy-duty drill with a paddle mixer attachment is highly effective. If you are working on a very large scale, a dedicated toe-behind papercrete mixer, sometimes called a toe mixer, is the ideal choice. Finally, you will need forms or molds to shape your papercrete. These can be made from wood, metal, or plastic, depending on the shape you want to create. Simple rectangular frames made from plywood are perfect for making blocks. For more complex or sculptural shapes, you can get creative with your mold making. Don't forget your personal protective equipment. Working with cement dust requires a dust mask to protect your lungs. You should also wear waterproof gloves to protect your skin from the alkaline cement mixture, and safety glasses to shield your eyes from any splashes. Safety should always be your first consideration before you start mixing. The first active step in making papercrete is transforming dry, shredded paper into a wet, uniform pulp. Start by filling your large soaking container about halfway with water. Then, begin adding your shredded paper to the water. Add the paper gradually and stir it as you go. This prevents large, dry clumps and ensures every piece becomes saturated. The goal is a soupy mixture, not a dense, compacted mass of wet paper. The soaking time can vary depending on several factors: the type of paper you use, the size of the shreds, and the water temperature. Thin paper like newspaper will break down much faster than thick cardboard. Warmer water will also speed up the process. Generally, let the paper soak for at least 24 hours. That gives water time to penetrate the fibers and start breaking them down. You'll know it's close when individual shreds lose their form and blend together into a more homogeneous slurry. Once you have a container of rich paper pulp, it is time to introduce the binder and any other additives. This is the stage where your slurry truly becomes papercrete. The ratio of paper pulp to cement is the most critical decision you will make, as it determines the final properties of the material. There is no single correct ratio. It depends on your intended use. For a lightweight, highly insulating mix, you would use a higher proportion of paper pulp. A common starting point is a ratio of 3 parts pulp to 1 part cement by volume. This creates a material well-suited for non-load-bearing infill walls. For applications requiring more strength or durability, you would increase the amount of cement. A ratio of 2 parts pulp to 1 part cement, or even equal parts pulp and cement, will result in a denser, stronger block. This is also where you would add sand. A typical mix with sand might be 3 parts pulp, 1 part cement, 1 part sand. The sand helps to fill the voids between the paper fibers, which reduces shrinkage as the papercrete cures and increases its compressive strength. It is always a good idea to make a few small test batches with different ratios to see which one best suits your project's needs. The mixing method is also important for achieving a consistent final product. For small batches, you can mix by hand in a wheelbarrow or a large bucket using a sturdy hoe or shovel. Be sure to wear your gloves and dust mask during this process. The goal is to distribute the cement powder evenly throughout the pulp so that every paper fiber gets coated. Break up any lumps of cement as you find them. Continue mixing until the slurry has a uniform color and texture, with no visible streaks of dry cement powder remaining. This manual process can be labor-intensive, but is effective for smaller projects. For larger quantities, a mechanical mixer is almost essential. Using a paddle mixer attached to a drill is a great option for batches up to 20 or 30 gallons. For anything larger, a dedicated cement mixer or a specialized toe-behind papercrete mixer is the way to go. These powerful machines make quick work of blending the materials, ensuring a thoroughly integrated and homogeneous slurry. Regardless of your method, the key is consistency. A well-mixed batch will cure more evenly and result in a stronger, more reliable final product. Take your time to ensure everything is perfectly blended before you proceed to casting. With your papercrete slurry mixed and ready, the next step is to give it shape. This is done by pouring or packing the mixture into forms. Molds. The design of your molds will define the final shape. For standard blocks, build simple rectangular wooden frames, using plywood or lumber. Construct bottomless frames on a flat, level surface covered with a plastic sheet. The plastic prevents sticking and eases removal. Build single molds, or large ladder-like molds, to cast many blocks at once. Filling the molds requires care to ensure a solid, void-free product. Scoop the slurry into the molds, overfilling slightly. Pack the material down firmly. Pack with your hands while wearing gloves. Or pack with a flat piece of wood. This compacts fibers and squeezes out excess water. It also helps eliminate trapped air pockets that make weak spots. After packing, use a straight-edged board, a screed, to level the top. Papercrete isn't limited to blocks. Create molds for wall panels, roofing tiles, or intricate sculptural forms. For curved walls, use flexible sheet metal or hardboard forms. For artistic projects, use buckets, bowls, or custom wire mesh armatures. For cast-in-place walls, build double-sided formwork. Pour slurry into the cavity and compact in layers as you go. This is poured-in-place or monolithic construction. Once forms are filled, you can often remove molds quickly. For simple bottomless block molds, lift frames off immediately after screeding. The wet mix is usually cohesive enough to hold shape. You can reuse the same mold right away to speed production. For complex enclosed molds or poured-in-place walls, leave formwork in place. Leave it for at least 24 hours to let papercrete set enough to support its own weight. Casting your papercrete is just the beginning. The curing process is where it gains its strength and durability. Curing is the slow, controlled drying of the material. Drying too quickly causes cracking and excessive shrinkage. Papercrete holds lots of water and shrinks as it evaporates. If the surface dries faster than the interior, internal stress makes cracks. Manage the drying environment to prevent this. Keep fresh blocks or walls out of direct sunlight. Keep them out of strong winds for the first few days. Lightly mist the papercrete once or twice a day for the first week. Especially mist in hot, dry climates. Covering blocks with plastic sheeting is effective. Plastic traps humidity, slows evaporation, and lets cement hydrate properly. Curing time depends on size of the piece. Curing time depends on mix ratio. Curing time depends on ambient humidity and temperature. A standard block, 2 to 4 weeks. A thick wall, several months. Perform simple tests to gauge readiness. Weight check. Weigh a block every few days. When weight stops decreasing, most water is gone. Hardness test. Press a fingernail into the surface. Hardness test. Press a screwdriver into the surface. A fully cured block resists indentation. Strength test for non-load-bearing blocks. Stand on one to check support. These tests build confidence before using the material. Problems still happen. Cracking is the most common issue from drying too fast. If cracks appear, increase humidity by misting. If cracks appear, cover more thoroughly with plastic. Soft spots or inconsistent texture. Blend the slurry more completely. Too brittle? You may have too much cement, or not enough fiber. Too soft and spongy? Add more cement. Troubleshooting is part of mastering papercrete. Treat each batch as a learning experience. One of the most immediate and striking properties of papercrete is its incredibly low weight. Compared to traditional concrete, which is famously dense and heavy, papercrete feels almost feather-light. A standard concrete block can weigh around 40 pounds, making it a chore to lift and place repeatedly. In stark contrast, a papercrete block of the same size might weigh as little as 10 pounds. This dramatic difference in density is fundamental to the material's character. It completely changes the experience of building, reducing physical strain and making construction a much more manageable task for a wider range of people, including those working on do-it-yourself projects without heavy machinery. The secret to its low weight lies in its composition. The bulk of the material is made from paper fibers, which are inherently light. These fibers, derived from recycled paper, create a complex, three-dimensional matrix. When the slurry is mixed, countless tiny air pockets are trapped within and between these fibers. While the cement adds some weight and provides binding strength, the overall volume is dominated by the lightweight pulp and air. This structure is fundamentally different from solid concrete, which is a dense aggregation of sand, gravel, and cement. The result is a material that is more like a rigid sponge than a solid stone. This lightweight nature has profound practical advantages during the construction process. Transporting materials to a job site becomes significantly easier and cheaper. A single truck can carry a much larger volume of papercrete blocks compared to concrete ones, reducing fuel consumption and transportation costs. This is especially beneficial for remote or hard-to-reach building sites. Once on site, the ease of handling speeds up the building process. Workers can move and place blocks more quickly and with less fatigue. This not only improves efficiency, but also enhances safety by reducing the risk of injuries associated with lifting heavy objects. Furthermore, the low density of papercrete reduces the dead load on a building's foundation. The dead load is the permanent weight of the structure itself. Because papercrete walls are so much lighter than concrete or brick walls, the foundation does not need to be as massive or heavily reinforced to support them. This can lead to significant savings in both materials and labor during the foundation laying phase of construction. For smaller structures like cabins or sheds, this might even allow for simpler foundation designs, making the entire project more accessible and affordable from the ground up. Beyond its light weight, papercrete's most celebrated advantage is its excellent insulating capability. The same trapped air pockets that make it light also make it a powerful barrier against heat transfer. Air is a poor conductor of heat, and the millions of tiny air bubbles captured within the paper fiber matrix work together to slow the movement of thermal energy. This means that in the winter, heat from inside the building has a difficult time escaping through the walls. In the summer, the intense heat from the sun is similarly blocked from penetrating the interior. This property is often measured by an R value, and papercrete boasts a significantly higher R value per inch than concrete, brick, or wood. This high level of thermal insulation translates directly into a more comfortable living environment. Homes built with papercrete walls maintain a more stable and pleasant indoor temperature year-round. They stay warmer in the winter and cooler in the summer, reducing the sharp temperature swings that can occur in less insulated buildings. This passive temperature regulation creates a cozy and inviting atmosphere without constant reliance on mechanical systems. Occupants experience fewer drafts and cold spots, leading to a greater sense of well-being and comfort within their own homes, a quality that is hard to put a price on. The benefits of this insulation extend to your wallet and the environment through significant energy savings. Because the building's shell is so effective at resisting heat flow, the heating and cooling systems do not have to work as hard or as often. This drastically reduces energy consumption. Over the lifespan of the building, the savings on utility bills can be substantial, often paying back any initial investment in the material many times over. For homeowners, this means lower monthly expenses. On a larger scale, this reduced energy demand lessens the overall strain on the power grid and decreases the carbon footprint associated with heating and cooling buildings. Papercrete is not just a thermal insulator, it is also an excellent acoustic insulator. The porous and irregular structure of the paper fibers is very effective at absorbing sound waves rather than reflecting them. This helps to dampen noise from both outside and inside the building. A home with papercrete walls will be noticeably quieter, shielding occupants from the sounds of traffic, neighbors, and other external disturbances. Internally, it reduces the echo and transmission of sound between rooms, creating a more peaceful and private indoor environment. This dual insulating property makes Papercrete a superior choice for creating comfortable, quiet, and energy-efficient living spaces.